Hello friends, I am going to discuss today about what is called the sorting of elements. It may be sorted. Sorting means arranging the elements in the ascending order, or we say the non-decreasing order, or the descending order, non-increasing order. We use the words non-increasing or non-decreasing to take into consideration the duplicate values. For example, for the numbers, unsorted numbers 10, 1, 12, 3, the sorted in the ascending order 1, 3, 10 and 12. Descending order is a 12, 10, 3 and 1. If you take the words, the unsorted words are who, she, he, why, and if they are sorted as per the dictionary order, it would have been he, she, who, why, and if it is in the arranged in the reverse order, it would have been why, who, he, she, and who. So broadly, the sorting techniques can be classified as internal sorting techniques and external sorting techniques. If you say internal sorting techniques, it makes use of the RAM, so it is faster. It is also faster. So when you go for external sorting techniques, to sort a very large number of numbers, we usually go for external sorting techniques. So they use auxiliary storage devices like tape, hard disk, etc. So there are number of techniques for internal sorting as well as the external sorting. So some of the internal sorting techniques, as I said, the main memory. We use the main memory for this. So the very frequently used sorting techniques as classroom exercises are selection sort, bubble sort, insertion, merge sort, quick sort, etc. Out of which I am going to discuss now about very simple sorting technique, what is called the selection sort. So where the elements are arranged either in the ascending or descending order. For example, if I take the elements as 10, 5, 13, 8 and 5. One important thing to keep in mind is if there are n elements, there will be n minus 1 passes. In each pass, observe that in each pass, one element is placed in final position. So let us begin our sorting with these numbers 10, 5, 13, 8 and 1. So what I do is, my idea is to arrange them in the ascending order. So what I do is, in the beginning there are 5 numbers, so I search for a number which is biggest. So biggest of all these numbers is 13. Then I shift it to the last position. Why? Because I want to arrange it in the ascending order. So this is my biggest element. This I shift to the last position. So thereby it looks like 10, 5, 1, 8 and 13. So you know that the biggest number in this is 13. Now my unsorted list is 10, 5, 1 and 8. In the beginning it is 10, 5, 13, 8 and 1. Now at the end of pass 1. So I say end of pass 1. In the pass 1 there are only 4 elements and the biggest element is placed to that. Now this is only my set of elements to be considered. Now what I do is, again, so out of the elements 10, 5, 1 and 8, this I am not going to consider because it is already in the sorted order. Now in this, the biggest element is this 10. So what I do is, the biggest element, again I shift it to the last position. So this is biggest. So I shift to the last element. Therefore what happens is, it looks like this: 8, 5, 1 and 10. The 10 is shifted here. And thereby this is how it looks end of pass 2. So the another element is placed in its final position. Now the elements to be sorted are only 8, 5 and 1. So what I do is, now I consider only the elements 8, 5 and 1. However, the other elements which are already presented are 10 and 13, so I am not going to consider them. So now these are only the elements which I am going to sort it. Now you observe that this is the biggest element. So this is biggest. So what I do is, now again I exchange with the last element. So 1 comes here, 5 here and 8 here. So it has been changed. So this is end of pass 3. End of pass 3. The end of pass 3, this is. So now what I am left with, I am only left with the numbers 1 and 5. So 1 and 5. And now again in this 1 and 5, where is the biggest? So the biggest element is 5 itself. And this itself is the last element. Therefore, no more exchanges. So I say this is end of pass 4. You will have only 1 and 5, and 5 is placed in its final position. So now there is only one element left over. So only when one element is left over, you say it is sorted. Now if you look at all the elements, so 1, 5, 8, 10 and 13, they are presented in the sorting order. So as I said, if there are n elements, there will be n minus 1 passes. So in the first pass, this is the end of pass 1, this is the end of the second pass, and this is the end of the third pass, this is the end of the fourth pass. So the elements are arranged like this. So in my next lecture, I will speak about how to write the code for this. Thank you.